in example 4, we're looking at a picture here where the Eiffel Tower, which is about 300 meters high, is projecting a shadow all the way to a distance of about 0.31 miles. The question is going to be, what is the angle of elevation of the sun when this photo was taken? Okay, so we know something about the height of the Eiffel Tower, and we know something about the length of the shadow. And then we also know that the sun is creating that triangle. So we have this triangle here. It's a little bit skewed in perspective, but it actually is going to be a right triangle. This angle down here is going to be 90 degrees because the Eiffel Tower and the land are perpendicular to each other. So I'm going to redraw that triangle over here. So we have our Eiffel Tower, and we have our shadow, and we have the sun creating that triangle. So this is 300 meters, and then we have 0.31 miles. So one of the first things that we're going to need to do is convert them so that they're in the same units. So let's go ahead and convert 0.31 miles into meters. And just for fun, I might as well use Google to convert that. So I just Googled convert 0.31 miles into meters, and we have that is about 498.8966 meters. Excellent. Okay, so now what we're looking for is the angle of elevation of the sun. And that actually is going to be this angle down here. The angle of elevation for the sun would be the angle that an observer looked up and saw how high the sun was. So this is our angle of elevation that we're looking for. Okay, so let's call that theta. And that's the angle I'm trying to find if I'm looking for the angle of elevation of the sun. All right. Now that I have these both in meters, I can use a ratio, and it's going to be of the opposite to the adjacent, so I'm going to use tangent. So the tangent of that angle is going to be equal to 300 divided by 498.8966, just so that they're both in the same units, they're both in meters. And theta then is going to be the arctan of that ratio. 300 divided by 498.8966. Okay, back over to Desmos. I got the previous question still up there, but that's okay. We're going to do arc tangent of 300 divided by our 498.8966. And so we find that we have a theta measure of about 31.02 degrees. All right, so the angle of elevation of this photo of the sun was at an angle of 31.02 degrees. All right, now if someone actually knew the angle of the sun that time of year in the photo, they knew when the photo was taken, we could calculate the time of day that this photo was taken. That can be interesting and useful. They use this type of measurement when they do forensic photography, and there's another example of that down at the bottom of this page, how time of angles of elevation, angles of the sun, can be used to predict time of day and can be used to discover if photographs have been like real or faked or all that good stuff. Alright, now let's take a look at the next page. We have another example up here. Two people on one side of a river are trying to estimate the width of the river. The first person stands directly across from a tall tree on the opposite side of the bank. The second person walks 25 yards along the same bank and measures the angle between the first person and the tree. So let's try to draw this situation. Okay. We want to measure the width of the river. So we have this river here, and we have two people. Oops, that one has like an arm. Okay, two people, and they are 25 yards from each other. the first person is directly across from a tree, and then the other person measured that the angle between the first person and the tree, so they're measuring the angle, so they're looking at they have a protractor in their hand, they're measuring the angle between when they're looking at person 1 and person 3, what the angle is. They're measuring this angle as about 65 degrees. Okay. Okay. All right. So what our goal is to know how far across the river it is. We want to know this distance. How far across the river are we? Okay. We have an angle that goes between person 1 and tree, and we have this distance on this side. So this angle would call that distance over there its opposite. Let's give it the letter X to use as its opposite, and then the 25 yards as its adjacent. So we're going to be using the tangent. So the tangent of 65 degrees is going to be equal to the opposite x over the adjacent, which is 25. If I multiply both sides by 25, 25 times the tangent of 65 is equal to x, and we can find x, that side, just by multiplying those two things together. Okay, so 25 times the tangent of 65, it's not a 30, 60, 90, it's just a 65, so I'm just going to use 65 as such. So that gives us 53.61 yards for x. Okay. So the river is 53.61 yards wide at that point. If you ever wondered how people measure big distances like rivers, they don't get a ruler out and stretch it across the river. They use trigonometry to get an estimate for its measure.